This is the table of characteristics of some types of resistors available in the market. Almost every circuit uses a resistor, but there are different types of resistors or different use of the same resistor. Hence, from this table, we can determine the type of fixed linear resistor to use. Here we can see the available range, maximum temperature, voltage, their advantages, and some applications. Let's say you want a resistor to have a long life and low cost, or you want a high precision resistor, or you just want an all-purpose cheap resistor for your projects. You can get a rough estimate of what's available in the market and how it will behave by following this table. But always look at the manufacturer's datasheet for better details. There are other types of resistors, we will explore them ahead. The wattage of resistors can be identified by the size, and you can identify most of the resistors by their appearance and color. But they are not a standard. Some manufacturers may have different sizes, shapes, but this may work for most of them, or look at the manufacturer's datasheet for precise details. Theoretical resistors have pure resistance, but real resistors have some capacitance and inductance due to the material and manufacturing process. This is its equivalent circuit diagram. Now, to select a resistor you need any two of these four quantities. Let's select a resistor for this LED with a voltage drop of 3 volts and a current draw of 20 milliamps connected to 9 volts DC source. Thus the resistor would need to drop the remaining 6 volts at 20 milliamps. And the value turns out to be 300 ohms. Let's say we don't have a 300 ohm resistor. Hence, we can use 3 100 ohms resistors in series, or we can select a higher resistor value of 330 ohm, which is available. Also, we can use an SMD resistor with code 301. The code 301 means 300 ohms. In SMD resistors, if there are numbers only, then the initial digits are the numbers and the last digit is the multiplier. Or if you see an R in the beginning or between numbers, then convert it to the decimal point and you have its value. Or if you see anything different, then refer to this table and the notes. Their wattage is also determined by their size. Now, after calculating the resistor value, we need to select a resistor based on its power rating, and the power through the resistor is 0.12 watts. Hence, we can select the 1/8 watt or any higher rating resistor. You would know that a LED is mostly a resistive load. Let's replace it with a resistor. And now you have is a voltage divider. Voltage dividers are to be used only for references. Using them to lower voltage and act as a power supply will cause issues. You can obtain any voltage with the voltage divider, provided it's between the two terminal voltages. Now, if we add more resistors, then we can have multiple points for referencing the voltage. If we keep adding the resistors and add another terminal that would just touch the resistors, we have as a potentiometer. Now we can adjust the voltage by moving the variable terminal across the resistive strip. They have another variant known as a trimmer. It also works the same but has a worm and worm wheel gear arrangement to make fine adjustments. Now, if we remove the third terminal, it becomes a variable resistor or rheostat. The potentiometer was connected in parallel, hence it is used to control the voltage. This rheostat is connected in series, thus it is used to control the current. The potentiometer, trimmer, and rheostat are electromechanical devices designed so that their resistance values can be easily changed. With these resistors, we have some resistors used for measurement, such as thermistor, used to measure temperature. A photoresistor used to measure the light. A very small value resistor or current shunt to measure the current by amplifying the voltage drop across the resistor. Then we also have some resistors to protect our circuits from overcurrent and overvoltage. First, we have is a fuse. It is made of such material that has characteristics of fusing without flames or without excess heat generation when the current load jumps suddenly more than required, thus protecting from overcurrent. And then this is a varistor. It is made such that its resistance varies with the applied voltage. As the voltage across the varistor increases, its resistance decreases, allowing more current to flow through itself, thus protecting the circuit. Looking at this varistor, you may remember another electrical component, the capacitor. So now let us look at the capacitors. This is the table of characteristics of some types of capacitors available in the market. Here we can see the available range, frequency characteristics, advantages and disadvantages, and some common applications. There are some more tables, charts, and graphs. Then there is this large table with more advantages and disadvantages. You can get a rough estimate of what's available in the market and how it will behave by following this table. But always look at the manufacturer's datasheet for better details. There are some other types of capacitors also, but these are some common capacitors. Theoretical capacitors only have capacitance, but real capacitors are complex. This is the equivalent circuit diagram of the capacitor. We have here ESR and ESL due to the material, design, and manufacturing process. Then, there is a leakage resistor. It is basically the resistance of the dielectric between the plates. Dielectric absorption is the name given to the effect by which a capacitor, that has been charged for a long time, discharges only incompletely when briefly discharged. Now, to select a capacitor you need these two quantities. Capacitance can be calculated depending on the use. And the voltage is the potential difference between two terminals with a polarized capacitor connected with the marked terminal to lower or higher potential only. The numbers on the capacitor give the maximum value that it can support. If you don't get a capacitor of the required value, then you can use a higher value capacitor or you can use multiple capacitors. When capacitors are in parallel, their capacitance adds up, and when they are in series their voltage adds up. Sometimes, multiple different types of capacitors are used. As you know, capacitors have some parasitic inductance, which is directly proportional to the frequency, and the capacitive reactance is inversely proportional to the frequency. Hence, as the frequency increases, the capacitive reactance decreases and the inductive reactance increases. The frequency where both are equal is called self-resonant frequency. If the frequency is further increased, the capacitor will now have more inductive reactance than capacitive reactance. Hence, we use multiple different types of capacitors to get a large range of lower impedance. Then there are supercapacitors. These capacitors have very high capacity. Supercapacitors can have capacitance up to 12,000 farads. With these fixed capacitors we also have some variable capacitors. As you may know, the capacitance of the capacitor depends on the overlapping area of the plates, the distance between plates, and the dielectric between them. Hence, we have capacitors where we can change the overlapping area or the distance between the plates to change the capacitance. They are known as variable capacitors or trimmer capacitors. They are used for tuning circuits. Now, after capacitors, we will look at the inductors. This is their table of characteristics. Inductors are just wire turned into a coil with or without a core. Hence, the only difference is their core material and their size. Some inductors have the same inductance but different sizes. It is due to the different number of turns. As the number of turns increases, the size of the required core decreases, thus the size of the inductor decreases. The equivalent circuit diagram of the inductor is the same as that of the resistor. Calculations of required inductance are pretty complex and it depends upon the situation they are being used. Hence, check for values in the circuit diagram or IC datasheets or try some inductors. With inductance, you should also look for the maximum current and the magnetic saturation current of the inductor, and do not exceed it. For more details always look in the datasheet. You can combine inductors in series and parallel to obtain certain values. There are also coupled inductors. They are used to electrically isolate two circuits but allow power to be transferred. If the winding ratio is different from 1:1, then it can act as a transformer. At last, there are some variable inductors. In these inductors, the core is moved to change the inductance or one of the terminals is moved, similar to the rheostat. All tables, charts, and graphs are available in the link in the description. Now you know how to choose a resistor, capacitor, and inductor for your circuit. Thank you for watching.